Hi, I'm Hara Yang from Washington State University. Thanks to everyone joining this session. In this talk, I will present our reflection and vision on language-agnostic dynamic analysis of multilingual code, promises, pitfalls, and prospects. Verifying program behavior using dynamic analysis is a crucial technique for ensuring software quality and hence mitigating these problems. Dynamic analysis has enabled a variety of software quality assurance applications, including, for example, dependency analysis, fault diagnosis, and security testing. In the meantime, the most recent study confirmed the status quo about software construction. Just 18% of the analyzed systems are written in single languages, while the percentage of multilingual software is over 80% and has been increasing over the past decade. From prior studies, systematic quality assurance of real-world software systems requires a holistic analysis of multilingual code. We cannot just analyze each language unit and then stitch the results together. On the slide, we can see that three examples show multilingual bugs in Java and C language combination. However, cross-language bugs are not only limited to Java and C in the real world. Besides, the relevant work has also found some bugs in other language combinations, for example, Python and C. Through the example we showed in the last slide, it is clear that root cause is that the defects originated in the code writing in one language are only manifested themselves in another language unit. So for now, our main problem is we should conduct a holistic analysis for multi-language systems of varying language combinations. State-of-the-art dynamic analysis of multilingual code, such as ORPS and its follow-up line of works, provides promising solutions. Since ORPS is the core of this line, we use it to reflect on the current state of multilingual dynamic analysis. As a state-of-the-art dynamic analysis of multilingual code, ORPS has two major merits. First, ORPS instrument at specified query, and the rest analysis is language agnostic, which means the ORPS is language independent. Second, the ORPS require no prior knowledge of the languages included in the multilingual code being analyzed. This implies that the analysis can be used in any multilingual software without significant additional effort. Now, let's see how the ORPS works. First, it instruments at the given query. Second, ORPS tries to delete one or more lines in the source code. Third, ORPS needs to compile the whole project after deletion. If compilation fails, it will recover the deletion and try a new deletion. Otherwise, it runs the entire project to get the output, to compare with the output of running the original source code. We can see that there is a loop in this analysis. Once ORPS compilation fails after deleting some code lines many times, it may be stuck in the loop for a long time. Above all, the efficiency and scalability of the language-agnostic methodology in this dynamic analysis appears to be a major obstacle for practical adoption. To validate that, we set up an experiment to assess the analysis in OPS. We select 10 open-source multilingual projects from GitHub as benchmarks. The evaluation metrics focus on the efficiency of OPS in terms of the cost of slicing time. Therefore, we set a time limit of 24 hours, a pretty high budget that a developer might potentially afford in practice. In addition, we also consider the resulting slice size as the size affects developers' use of the analysis results. As shown in the table, only this project saw some queries finish within 24 hours. OPS times out for any queries out of the other subjects. For the only 27 queries it returned a slice for, the average cost was 9.5 hours per query. The OPS dynamic analysis lacks of knowledge, which lead to its being uniformed, hence opportunistic in line deletion. This mechanism results in a large number of failing attempts of deletion. As we observed during the experiment, it was indeed stuck in the deletion and combination loop for a long time until the timeout is triggered. Generally, for a multilingual dynamic analysis, if we consider the trade-off between scalability and language independence, the OPS is at the position indicated by the red dot. OPS face critical practicality barriers as it lies at one extreme here. A more practical design should strike a better balance between language independence and scalability. For better balance in language independence and analysis practicality, we propose a high-level design for dynamic analysis of multilingual code to decouple analysis algorithm, including dependence, computation, or slicing, from the process of collecting the program data needed by the analysis. This design minimizes language-specific analysis, maximum language independence, and achieve analysis extensibility by decoupling analysis algorithms from semantics of specific language by harvesting language-independent data. In summary, first, the feature multilingual dynamic analysis should make a better trade-off between language independence and scalability. Second, analysis extensibility can be achieved by decoupling analysis algorithms from specific language semantics, minimizing language-specific analysis and collecting language-independent data. For more details, please check out our paper. Thank you for watching. For any questions, please contact me via my email here. Thank you.